Okay, welcome to video 2. Just going to carry on here. I'm going to let you guys go ahead and do 3, 4, and 5. Remember for 5 when you guys go through and do it though that you got something in meters and you got something in kilometers. I would probably change that to one or the other right off the bat. So either change meters to kilometers or kilometers to meters. And remember that there's 1,000 meters in 1 kilometer. And you can also see that on your formula sheet too, if you go from your unit conversion. Okay, going on down. Okay, so for this one, it says Natasha can buy a 12 kilogram turkey from her local butcher for $42.89. The local supermarket has turkeys advertised in its weekly flyer for $1.49 per pound. They're about 2.2 pounds in 1 kilogram. Which store has the better price? So here's the problem: is we've got something in kilograms, we got something in pounds. We need to be able to compare the two. So what I'm going to do for the butcher, let's convert to kilograms. We could convert this one to pounds. It doesn't really matter which one you do, but let's convert the pounds to kilograms. I'm just kind of randomly choosing that one. So if we did that, let's first off just figure out how much the butcher pays per kilogram. So just like we did before, we'd say 42.89 divided by 12 kilograms. This is going to let us know how much it is per 1 kilogram if we divide them. So that's going to be 3. What do they have? 3.57. $3.57 per kilogram. So we're in the units of per 1 kilogram right now, right? Up here where it says that we're trying to compare it to $1.49 per pound. So that's the problem. So what I'm going to show you next is something called unit analysis. So if we right down here, we're going to go like this. We're going to go $1.49 per 1 pound. Right, so that's my unit there. Now what we're going to do for these unit analysis ones is we're going to multiply by something to change these pounds into kilograms. And by something, we're going to put a bracket, and it's going to be something over top of something. And that something over top of something is going to come from up here. It says that there are 2.2 pounds in 1 kilogram. So what I'm going to do is put pounds on the top, so LB, and then kilograms on the bottom. And it says that there are 2.2 pounds in 1 kilogram, so I put 2.2 over 1. And the reason why I put the pounds on top and not the kilograms on top is because now you can see that if I look at my units, I've got pounds on the top of the equation, and I've got pounds on the bottom of the equation. So what's going to happen there is now that I can cancel pounds on the top with pounds on the bottom. So if I just multiply 1.49 times 2.2, I'm left with kilograms on the bottom. So it's 4.49, or sorry, whatever this will be. Let's maybe put that in. So it ends up being $3.28 per kilogram, right? Because it was over kilogram. Maybe I should write that like this. So over kilograms, 1 kilogram. So yeah, we'll practice this a bit more with that unit analysis, but that's the basic idea of changing units. So now we just have to compare. So now we've got something. This is the first one was 3.57 per kilogram. This one's 3.28 per kilogram. So the second one was a better deal. The supermarket was a better deal. All right, moving down. So I'm gonna let you guys do 7. I would just recommend, there's a few ways you can go through these, right? I could change these both, like I could do the first one, right? And go pounds and dollars, just divide this one by this one and figure out, how many dollar it is per pound, and then do like we did on the last question. But what I'd probably recommend, and it'd probably be easier, is just change 3 pounds into kilograms right off the bat. Because if you change it into kilograms right off the bat, now we just have to do what we were doing in the first ones, right? In the last video, you're just gonna go, this dollar value over this in kilograms, and then that's going to be able, you'll be able to compare that to this one when you're done. So to make sure you know how to go pounds to kilograms, you can either go to your formula sheet, and it does say there's 2.2 pounds per 1 kilogram, or in the question right above this one it says the same thing too, right? So maybe let's just make sure you go the right way with that. I'll show you how to do that one. So it'd be 3 pounds, so 3 lb. And if I want to change that into kilograms, I do the same type of thing. So I'm going to have lb on the bottom, right? And there were 2.2 pounds in 1 kilogram. So the reason why I put lb on the bottom, or my pounds on the bottom, is because now they're going to cancel, right? I've got pounds on the top of this side. They're going to cancel with pounds on the bottom of that side. So now I've got 3 times 1 over 2.2. That's the same thing as just saying 3 divided by 2.2. And if you do that, you'll end up with an answer in kilograms. So hopefully that made sense. Okay, yeah, so I'll let you guys finish that one. Okay, so let's do 8. If you were traveling in a car moving at a constant velocity of 44 kilometers an hour for 50 minutes, how many kilometers would you have traveled? So what I think is going to be most helpful right now is if minutes and hours, if we had them in the same units. So you could either change hours into minutes or minutes into hours. I find if you've got one that only has 1 unit, you know, it's not something over something else, it's kind of easier just to change this one into probably hours first. So let's do that. So if I was going to change that into hours right off the bat, all you'd have to do, if you want to figure out how many hours that is, if you think about it like cross multiplying, I know there's 60 minutes, or 60 minutes in an hour, right? So the way I do this is setting up a ratio. I kind of like to think about it this way. So there's 60 minutes in an hour. So let's, if I had 50 minutes, so 50 min over 60 min, and why I'm doing that is because there, I want to set up a ratio here. So I want to have 50 minutes out of a total of 60 minutes, right? It's going to be the same as something over 1 hour. Right? So the ratio of the smaller over like the total, right, is going to be the same as this one. So all I got to do here now is just cross multiply. So 1 times that divided by that, which it really just is the same thing as, so 1 times 50 divided by 60 is the same thing as just 50 divided by 60. So if you do that, you end up with 83. Or sorry, 0.83. 0.83 hours, right? So what we had. The other way of doing that, I just kind of want to show you 2 ways, because that was the kind of the ratio way of thinking about it. The other way is just like we were doing before. So if we had 50 minutes, I know that I can multiply by some kind of ratio, right? I'm going to put minutes in the bottom. I'm going to put hours in the top. I put minutes in the bottom, right, because I want to cancel them. I know that there are 60 minutes in 1 hour. So if I do that, now minutes are going to cancel with minutes. And now I still have 50 divided by 60, and you get the same thing. So this would end up being 0.8, oh, what do they say? 0.83 hours. And then I'd set this up with as a ratio again. So if I rewrite this as something that would make a bit more sense, if I rewrote that as 44 kilometers and then over 1 hour, because that's really what I'm saying, right? 44 kilometers per hour. That's what that means. I'm going to say, well, that's going to be equal to, and then I'm going to put it over 0.83 hours, because if I do that, now what I have up here is going to be the same, right? So if you're able to go 44 kilometers in 1 hour, how many kilometers will you go in 0.83? So again, you see we've got this situation where we can just cross multiply. So it's going to be this times this divided by this gives you that. So if you do that, you end up with x being equal to 36.5. And you can see that all we really did here was we just multiplied 0.83 times that many kilometers an hour, right, to get your answer. which kind of makes sense, right? This one was a decimal, so it didn't make, like, it wasn't as obvious. But let's say that this down here, the number we were looking for was like 4 hours. All you really have to do is go 4 hours times 44 kilometers per hour. So yeah, so a few ways of doing this. I want to show you kind of both there. Okay, so this one says Christina plans to travel in Australia. What Canadian dollar amount will Christina need to convert if she wants to travel with $1,500 Australian dollars in traveler's checks? So let's just set up a ratio again. We've got three numbers here. They're going to be the same three numbers that we're going to put into our ratios. So it says $1 per Canadian is equal to 1.3456 Australian. So let's just put one of those over the other one. It doesn't actually matter which. We can just say, you know, $1 over 1.3456 is equal to, and now let's just put that over. The one thing you just have to make sure you do is the bottom one was Australian, right? So on the other side of the ratio, this also has to be the Australian one. So this will be $1,500. And we can see that we've just set up a ratio, right? This ratio is going to be the same as what I need on this side. So it's just going to be $1,500 times 1 divided by 1.34. And that gives you that. And if you do that, you end up getting 1,114.7, or I guess 70 cents is how you should write that with money. Okay, so that's it for that one. I'm going to let you guys go ahead and do that one on your own because it's similar to the one above. It'd be good practice. This one says the graph shows how a cyclist travels over time. So D is equal to RT. And whoop, that didn't make any sense. This R should be a V. It looks more like an R than a V. So D is equal to V times T. So that means distance is equal to velocity or speed times time. Okay, this one says, over which interval is the cyclist traveling the slowest, fastest, and not at all? Okay, and for this one, I'm going to rewrite this formula a little different. I'm going to write this as V is equal to D over T, or velocity is equal to distance over time. Just because I think it'll make a bit more sense with our graph here. So the question says, which interval is the cyclist traveling the slowest, fastest, or not at all? The not at all section, if you think about it, we've got distance, right? Right at this point from D to E, the distance doesn't change. It stays 5 the entire time, right? So that's going to be your not at all. It's going to be from D to E. The slowest rate, or the slowest velocity, if you kind of see here, it's going to be, well, if we look at maybe this one, we've got, this goes from this point, let's go from B to C is what I'm looking at right now. So from B to C, you can see that the distance it covers is 1, 2, 3. It goes up 3 from there to there. And it goes over, the time scale goes from 15 to 35. So 20 minutes. So 20 minutes from this point to this point. So let's even write that. So we got 3 kilometers, and this point is 20 minutes. So really, you've got a distance up, and you've got a time going that way. If we relate this to our graph or our formula we have over here, the velocity at that point is going to be 3 kilometers over 20 minutes, which is equal to 0.15. Well, that should have been kilometers per minute. Okay, so yeah, so that's that kind of speed. That is actually going to be our slowest, because you can see if I compared this one, you know, let's say from A to B, this one's going up 1, 2, 3, 4, 5. So the distance is going to be a big number, right? 5 over 15. It's going to be a bigger number than this one. And you can really, what you can see is that the slope is what matters. The more slope you have, the faster it's going to go. The least slope it has, the slower it's going to go. And that doesn't actually change on this side. You can see as we're going down here, the distance is going, you know, down this way. that doesn't actually really mean anything. All it means is that we're going in the other direction now. But still, we're going down, 1, 2, 3, 4, 5 kilometers down. And it's going 5 kilometers in 10 minutes going down, right? So that just means that you're going in a different direction. So the fact that it's going down doesn't mean that it's going slower. It means that it's just going a different direction. So really what we're looking for the slowest one here was the one that had the least slope. The fastest is going to be the one that has the most slope. So the most slope in this case would be, actually it looks like it would end up being A and B, and G and F. Look like they'd be exactly the same. Yeah, just in opposite directions. Oh, maybe not. Might be C to D. I'll let you guys figure that one out, which one actually is the fastest. Okay, now this one says convert the fastest time to kilometers per hour. I'm not exactly sure what the fastest time was, but I'm just going to give you an example. Let's say that we had a number that was like, I don't know, 4, and our units were up there, were in kilometers per minute. We want it to be in kilometers per hour. So, maybe I should write minute MIN too. What we have to do is multiply by some factor. That's so I'll give you guys that hint, and I'll let you finish that to change it into kilometers per hour. And I made that video way too long, so make sure you guys do the homework questions, and I'll end the video there. So see you guys in class.